let's solve for the matrix polynomial P of matrix A using the given matrix and this given polynomials here. Take note that if we are going to use the P of A, we are going to treat our result as matrix later. Let's start with the first unknown. We'll have P of X is equal to X minus 2. So if we are going to use or solve for P of A, we are just going to use A as the automatic substitution for X, and our constant here would be 2 and I, 2 multiplied to I. That's what will happen to all constants in solving for matrix polynomial. Hence, we will have here our entire A, 3, 1, 2, and 1. Then minus 2 times I, which should be the same size of our A, so that the difference or the sum, if it's addition, would be defined. So that's 1, 0, 0, and then 1. And then we have it here. This is still 3, 1, 2, 1. Minus, you will have, close this one, 2, 0, 0, and 2. This is why the result for the P of A for the first given polynomial is a matrix of 1, 1, 2, negative 1. For the next item, which is the P of X is equal to 2x squared minus x plus 1. So we are going to, again, substitute matrix A to all x. So you have 2a squared minus a plus 1i, or you can just simply use I because the scalar is just 1. Now, for a squared here, a squared is, of course, the result when we multiply a by a. So before we apply a squared here, let's solve for a times a, which is the product of 3, 1, 2, 1 to itself. 3, 1, 2, 1. Okay. The product now would be, let's start it, let's do it step by step. Okay. So you have 3 times, we will have, again, for the matrix multiplication, the row of the first matrix to the column. And again, since both of them are a square matrix, specifically 2 by 2 for matrix multiplication, 2 by 2 times 2 by 2, we will expect a defined result of 2 by 2 as well. So again, we'll have, let me erase this first here, right? So 3 times 3 is 9. 1 times 2 is 2. So 9 plus 2 is 11. Next, the same row to this column. So since they are all 1, so 3 plus 1, you will have a result of 4. Then, we will have the next row to the first column. 2 times 3 is 6. 1 times 2 is 2. So 6 plus 2, this is 8. And finally, the same row to the last row. And since they are both 1, you just simply have 2 plus 1. So that's 3. So this is now the matrix you're going to multiply here. So 2 times a squared, which is 11, 4, 8, and 3. Okay? Let me do it again so that we'll have enough spaces here because we still have minus a and plus I. So you'll have here 11, 8, 4, and 3 minus a, the original matrix, 3, 1, 2, 1, plus identity in a 2 by 2 matrix, 1, 0, 0, 1. So your matrix polynomial P of A is equal to, so we simply use the operations, 11 minus 3 plus 1. So you have a result of, by the way, I forgot to show that this is still with a scalar 2 because we have the 2 here. So let's try to multiply first. Pardon. So you'll have 22. That's for the first. You will have 8 here, 16, and 6. Subtracted with 3, 2, 1, 1, and added with an identity. So this is not the final result for the matrix polynomial P of A. So the result will be 22. Let's use another color for the operation. 22 plus 3 is minus rather is 19 plus 1. You will have a result of 20. 20, that's 20. Next, you will have 8 minus 1, 7, plus 0, I have 7. Next, 16 minus 2 is 14, plus 0, 14. And finally, you will have 6 minus 1 is 5, plus 1 rather is 6. So this is now your matrix polynomial for the second situation. Okay, so let's have the last one here. So we'll have triple I, and the matrix polynomial is, rather, the given polynomial, not that we'll have P of x is equal to x cubed minus 2x plus 1. So our given matrix A, I'm also going to copy it here so that we will not be scrolling from time to time. 3, 1, 2, 1. So we'll have this as our last item for this video. So we will have it here for P of A. We'll have A cubed minus 2A plus 1I, or simply, again, just I. Now, with difference to the previous example, we'll have A cubed, which is A times A times A. Since we already have this result earlier, looking back here, this was our A squared. That's A squared times A. So A squared times A squared is 11,483. 11,483 to be multiplied with 3,121. Whatever be the result here, that would be our A cubed, and substitute here in our process. So let's multiply. You will have this first row to this first column. 11 times 3 is 33. 4 times 2 is 8. 33 plus 4, you will have 33 plus 8 rather, 41. That's correct. Next, same row but different column, and since they are both 1, you can simply have 11 plus 4, 15. Next, this row, 8, 3 times this column. 8 times 3 is 24. 3 times 2 is 6. 24 plus 6, you will have 30. And finally, this same row to this last column, and again they are 1, so 8 plus 3, you will have a result of 11. This is our matrix to be substituted here. So we will have again same as earlier. Let's have a lot of spaces here. So P of A is now 41, 15, 30, 11 minus 2 times your A, 3, 1, 2, 1 plus identity 1, 0, 0, 1. So before we add, let's try to get the result of this. 41, 15, 30, 11 minus 6, 2, 4, 2 plus 1, 0, 0, and 1. So if we're going to do this, okay, this is where will be our final result. 41 minus 6 is 35 plus 1. That's 36. Next, 15 minus 2 is 13 plus 0, 13. Okay. Next, you will have 30 minus 4 is 26 plus 0, you will have 26. And finally, for the last, 11 minus 2 is 9 plus 1, you will get 10. So this is the matrix polynomial for this given equation here. So this is how we solve matrix polynomial for a specific matrix given. But again, one thing to be not to forget here is if you have here constant just like 2, 1, and 1, it will be the scalar value should be multiplied to an identity. And since our given is a 2 by 2 matrix, your identity is also a 2 by 2 matrix. But if this is 3 by 3, then definitely your identity should also be 3 by 3. Thank you very much for watching.